Let's get the ultrasonic sensor first. Okay, let's type our code. First of all, we are going to start with the libraries. Let's connect the yellow LED. We will do the same thing. Positive will the Hi guys, this is Murat from Harman School of Innovation, El Paso, Texas. In this challenge, you will create a sensor for a car that will alert you of any obstacles when you're parking your car. You will start with some instructions and then modify what you're making to create a personalized project. Your car reverse parking sensor can detect if any objects are very close, or far away. Maybe your car reverse parking sensor will alert you of the proximity of the objects using light, sound, or both. Let's get started. Alright guys, I would like to start with the kit parts used in the circuit for our project. First of all, we have a PyTap 3. We have a PyTap Proto Plus. We have a one red, one green, one yellow LED, one ultrasonic sensor, one buzzer, bunch of jumper cables. We have 300 ohm resistors. We have one 330 ohm resistor, one 470 ohm resistor. Also, you will need a kind of toy car or another wheeled object and a tape or rubber bands or other ways to connect components to the car. Now we are going to connect the ultrasonic sensor. Let's get the ultrasonic sensor first. We will need 4 male to female cables. We're gonna need a 330 ohm resistor and 470 ohm resistors. You will also need PyTap Proto Plus. This is our breadboard. We will connect all our components on this board. To connect the ultrasonic sensor to PyTap Proto Plus, let's see the diagram on the screen. Okay, you need to make sure that you're gonna connect the cables on correct places. First one is the VCC pin. It will go to the 5-volt power on the PyTap Proto Plus. Second one is the trigger. It will go to the GPIO pin 23. Third one is the echo, goes to the GPIO pin 27. We have the 2 resistors. This pin will go to 470 ohm resistor, and then between 2 resistors we are gonna go to the pin number 27. And the last one is the ground. It will go to the ground on the PyTap Proto Plus. Okay, let's continue with the assemble. First of all, I'm going to connect the jumper cables to the sensor. Okay, like this. And then I'm going to connect the resistors first. First resistor is the 330 ohm. One of the leg goes to the negative, and the other one goes to the one of the row here. The other resistor is going to be the 470 ohm. I'm going to connect one of the leg on the same row, and then other leg will go to the another row like this. And then this is our first pin from the sensor. It will go to the 5 volt, which is here. Okay, second pin will go to the GPIO number 23, which is on the top row on the GPIO pins, and number 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, third pin will go to the 407 ohm resistor. This is the empty leg, and then the last one will go to the negative. Now I need one more jumper cable to connect from the between resistors to pin number 27, which is number 7 on the bottom row. Okay, now we need to extend the jumper cables to able to connect the sensors to toy car. You can use a tape, rubber band, or some other method to attach the ultrasonic sensor to the back of the car. In our case, I will use hot glue to attach the sensor. Now let's extend the cable first. I'm going to take off the sensor. I'm going to use the same length for jumper cables, male to female. Just make sure they are in the same order. Okay. And I put back the sensor. Okay. I'm going to use this toy car to attach this sensor. Okay, I attached the sensor to the car by using the hot glue gun. Now we are done to connecting the sensor. Let's open the software and start typing our code to test that ultrasonic sensor works or not. Okay, let's open our software. Okay, let's open our application and type our code. I'm going to use the Mu as a Python editor. Okay, let's type our code. First of all, we are going to start with the libraries. Okay, from GPIO 0 library, I'm going to import the LED and buzzer. first, second, from PT Proto Plus, I'm going to import the sensors. And from time library, I'm going to import the sleep. Okay, let's define our ultrasonic sensor. Let's while loop. Okay, in the while loop, while it's true, it will get the distance from the ultrasonic sensor and it will print this distance, and after that it will wait 0.1 seconds. Okay, let's try our ultrasonic sensor. Is it working or not? I'm going to click on the run. On the bottom, it's showing us the distance from the object to the sensor. I'm going to move the car. As you see, it's changing, decreasing. Okay, next part is the add more components to our circuit. Let's get started. For this part, we will need a red LED, a yellow LED, a green LED, a buzzer, 5 male-to-male jumper cables, and 300 ohm resistors. Okay, let's start to add more components to our circuit. Before you start, you need to know that LED's long leg is going to be positive. This connects via the jumper cable to GPIO pin, and the short leg is the negative and goes to ground on the PT Proto Plus. The long leg of the LED must be on the same vertical line as the jumper cable, and the short leg of the LED must be on the same vertical line as the resistor. Okay, let's start to connect our red LED first. Okay. As you see, there's a line on the Python product plus. This separates the top part and the bottom part, and you are gonna able to connect the LEDs like this. I'm gonna put the positive flag on the top part, negative flag on the bottom part. Okay, let's start with the negative flag. Resistor will go to the same line on the negative flag, and then others flag will go to the negative on the Python program. Like this. And a positive leg will go to number 4 pin on the Python program, which is gonna be bottom row and number 4. Okay. Let's connect the yellow LED. We will do the same thing. Positive will go on the top part, negative will go on the bottom. And the resistor will go to the negative, then negative leg of the LED. Like this, and then positive leg will go to pin number 14, which is top row and number 4. Okay, let's connect the last one, green LED. First it goes to top and it goes to bottom. Resistor goes to negative and then negative leg of the LED, and then positive will go to the number 15, which is top row number 5. Okay, since our Python product connected to Python, the green LED on right now. Okay, let's add the buzzer as the last component to our circuit. Okay, as you can see, there's a circle plus sign. This shows the buzzer have a positive and negative legs. This side is going to be positive side. Left buzzer here. Negative. And positive will go to the number 17, which is bottom row number 6. Okay, we are done with the add-on components to our circuit. Now we can get start typing our code for the new components. Okay, let's start with initialize the new components to our program. Part I'm gonna put a sequence. It will initialize when I click on the run button. It will light on the LEDs one by one to check is it working or not. Okay, let's try the code. Is it working or not? I'm going to click on the run button. As you see, LEDs light on one by one and buzzer went on 1 second and then it turned off. Our components are working right now. Now you have tested the ultrasonic sensor, the LEDs, and the buzzer. You can use some code to link them together so that the sensor controls the other components. The code in this part will allow the reading from the ultrasonic sensor to control the LEDs and buzzer. Okay, the code in this part will allow the reading from the ultrasonic sensor to control the LEDs and buzzer. This code is another while loop, while true loop. The beginning of the loop is the same as it was we did before. But now after the statements to read the distance from the ultrasonic sensor and print the reading, there's a conditional. This conditional does the following, which is if something is within 30 centimeters of the sensor, turn on all the LEDs and the buzzer, or else something is within the 60 centimeters of the sensor, it turns on the LEDs but not the buzzer. If neither of these conditions are true, it turns off all the components. Let's get started typing our code. Okay, let's try our code. I'm going to click on the run button. I'm going to hold the card here. Okay, as you see, now its sensor is showing 32, 33 centimeters. I'm going to get closer. Under 30 centimeters, as you can hear, LEDs are on and buzzer on. I'm gonna move back. Okay, I'm increasing the distance. After 60 centimeters, as you see, LEDs are off and buzzer off. Okay, let's play with the distance numbers and let's make it a little bit closer. I'm gonna get closer. It should start on 15. Right now it's 13. As you see, LEDs are on, but not the buzzer. I'm gonna get closer. Right now is 4 centimeter and LEDs and buzzer are on. Okay, I will change the code a little bit different this time and let's see what's gonna happen. Okay, let's try our new code and see what's gonna happen. I'm gonna click on run. Okay, I changed the distances to 5, 10, and 15 centimeters. When I get closer to 15 centimeters, the green LED will flash and buzzer will beep. When I get closer, less than 10, green and yellow flashes right now and buzzer beeps faster, and then less than 5, all LEDs and buzzer is faster right now. Okay, we can be more creative. We can add more components like button, and you can change your code and make different applications with the Python. Alright guys, this was basically the car parking sensor made with the Python 3 by using the Raspberry Pi and Python programming language. As I mentioned before, you can change anything you want or add more components to create different projects. Just use your imagination and see you in the next tutorial.